Okay, kiddos, this is just kind of a supplementary lesson along with 3 or 4 worked problems on completing the square. So what I wanted to start off to do is really talk about that in solving quadratic equations, why we're doing all this stuff, why we can't just solve it regularly. So if we have something like x plus 7 equals 23. Okay, we can just go ahead, subtract 7 from both sides, and we get x equals 20 or 16. And that's fine. Now if we have x squared plus 7 equals 23, we can still subtract 7 from both sides, and then we get x squared equals 16. Now notice here that, and it's important to understand the ultimate intent of algebra is to solve for our variable. So if I have x squared equals 16, that's not, hey Jacob, that's not actually a, hey, can you let Coco out? Huh? Oh, she's in the room. But if I have x squared equals 16, oh, she's just being a brat. Okay, sorry. I haven't really solved for x. I've solved for x squared. So I need to do something additionally. No, she was in the room, huh? So that gives me x equals plus or minus 4. So there has to be, when we're using squares, an extra step which gets rid of that square. If we have something like this where we can get the x squared all by itself equals something, then we can just square root and use whatever the answer is. However, so if we have x times x equals 0, x equals 0, but what if we have something like this? X squared plus 6x plus 8 equals 0. Well, we can't really solve for x here. We can subtract 8, that gives us x squared plus 6x equals 8. Take the square root of that, and we have what? What's the square root of x squared plus 6x? I don't know. Square root of 8 is like 2 radical 2, but that doesn't do me any good because I can't get x equals whatever over here. Okay? So can't do that. But if I have x squared plus 6x, woo! If I have x squared plus 6x equals 8, subtract 6x from both sides, that gives me x squared equals negative 6 plus 8. And I take the square root of both sides again, I'm going to have an x on the left-hand side. But then on the right-hand side, I end up with the square root of 6x plus 8. And notice that I'm then solving for x, but part of my answer is x. So instead of being able to say something like x equals 4, x equals 17, or x equals pi, I'm sitting there and saying x equals 2x. Well, that's not good enough. I need to be able to have all my single variable on the left or the right-hand side of something, the equation, and everything else on the other side. I can't have x in 2 places if I want to solve for that variable. So there are a couple ways that we can do this. The first we call factoring. So if we have something like x squared plus 6x plus 8 equals 0, that factors out to x plus 4 times x plus 2 equals 0. We then came up with the... So if we factor that out to x plus 4 times x plus 2 equals 0, we're then able to use the zero product theorem. Remember, the zero product theorem says that if we have two things, here and here, that are multiplied to equal to 0, then one of them has to be 0. So we can set this up as x plus 4 equals 0, or x plus 2 equals 0, and then solve each one of those equations, And by rewriting this trinomial right here as the factor of two binomials, we're able to separate that x squared. We're able to set up that x squared in a position where we can get it by itself. Well, sometimes that doesn't work. Sometimes you can't factor. And that's where completing the square comes in. So let's say I have x plus 2 squared equals 16. Well, I can just square root both sides, and I get x plus 2 equals plus or minus 4. Subtract 2 from both sides, that gives me negative 2 plus or minus 4, and that's negative 6 or 2. So notice that if the x is on the inside of something that's squared, then I can get rid of that square by using the square root. Okay. But what if what's going on here? So, let's look at this a different way, though. Let's take away the 0 and just look at x plus 2 squared, which equals x plus 2 times x plus 2. Now, if I FOIL that, if I use the distribution property of multiplication, I get x squared plus 2x plus 2x plus 4. I combine my middle terms. Let's say that equals 16. Okay? So now I have x squared plus 2x, or plus 4x plus 4 equals 16. Okay, so notice that if I subtract 4 from both sides, I'd get x squared plus 4x equals 12. Okay? So let's say that was my problem. Well, I know that this right here, that x squared plus 4x plus 4, equals x plus 2 squared. So if and x plus 2 squared, I can take the square root of to get x by itself. So if I have something like this right here, x squared plus 4x, I think to myself, I go, self, how do I make that x squared plus 4x turn into something like x squared plus 4x plus 4 that I can then use to turn into x plus 2 squared, which I can then take the square root of and get x by itself? Well, we already know the answer. We know that the answer is we add 4 to both sides. Now, that act of adding 4 to both sides, that allows me to sit there and, again, turn x squared plus 4x plus 4 into x plus 2 squared, which allows me to square root to get x by itself. So that act of adding the 4 in is called completing the square. Because what I did was I added a number in there which then allowed me to factor out x squared plus 4x plus 4 into a perfect binomial square, in this case x plus 2 squared, which I could then take the square root of and therefore solve for x. So that is the theory of it. What we're doing is we're trying to create on one side of the equation, the one with all the variables, the product of a perfect square of binomials. Once we create the product of a perfect square of binomials, we can rewrite it as the binomials themselves. And once we get the perfect square of the binomials themselves, then we can take the square root, solve for x. So that's what we're doing. So let's say I have x squared plus 4x equals 12. So let's say we didn't just do that problem, and so we don't know that the answer is 4, and we have to figure out what it is. Well, based on stuff, it's called binomial theorem. We're not going to get into it. Here's how we do this. We know that A equals 1 and B equals 4. So the relationship that we really care about here is B over 2A. In this case, that would be 4 divided by 2 times 1, or 4 divided by 2, or 2. So we know that B over 2A equals 2. So before I go any further, if you're watching this video, you should absolutely 100% have your notes in front of you, so that when I'm telling you this, you can also be looking at your notes and going, oh, that's what he meant. Okay? So we know that B over 2A equals 2. So that means that B over 2A squared equals 2 squared, or equals 4. So in order to complete the square here, we know our first step is to add B plus the square root of, or B over 2A squared to both sides. Now, because now you should look at this and go, oh, we just completed the square. So before we had x squared plus 4x, but I used this process to find the exact I just completely lost my train of thought. So we use this process to find the exact number, which when we add in, we'll complete the square, which we will then be able to factor to a perfect square. And in this case, that's x plus 2 squared equals 16, and then we just go from there. And we're already there. Or we have already done that on the previous page, so we know how that works. So now that we've gone over kind of the theory of what completing the square is, I do want to go over the practice of it. So let's look at number 1. I know we did number 1 in class, but we're going to add 71 to both sides, because remember, when I gave you those steps, the first step is write out as ax squared plus bx equals negative c. So we add 71 to both sides, and we end up with 10b squared plus 20b equals 80. So the first thing we want to do now is, we know that a is 10, b is 20, b over 2a is going to be equal to 20 divided by 20, or 1. And that means that b over 2a squared is 1 squared, which is also 1. So, step 2, we divide by a. So we're going to divide it, we're going to divide everything by 10. 10 divided by 10 is 1. 1 times b squared is b squared. 20 divided by 10 is 2. 2 times b is 2b. Or not 2b. And 80 divided by 10 is 8. So now what we're going to do is we're going to take this number right here, that 1, and we're going to add it in. If we do it to the left side, we got to do it to the right side. So now we have b squared plus 2b plus 1 on the left-hand side. And 9 on the right-hand side. Well, based on what we just did, because we added that 1, we then created something that we can factor into a perfect square. And what we're doing is we have b plus 1, which is that b plus 2a, squared equals 9. We're going to take the square root of both sides, and we have b plus 1, and we have b plus 1 equals 1 plus or minus 3. Or b plus 1 equals plus or minus 3, subtract 1 from both sides, and we get b equals negative 1 plus or minus 3. Which gives us 2 or negative 4. So moving on. So let's look at number 2. So here what we're going to do is we're going to subtract 2 from both sides. So we have 3x squared minus 12x equals negative 9. Now, I know that a equals 3, b equals negative 12. So b over 2a is going to be negative 12 over 2 times 3. Or negative 12 over 6. I'm not doing good at this today, guys. Sorry. Or negative 2. So that b over 2a squared is going to be negative 2 squared, or 4. So we want to divide by a, and that gives us x squared minus 4x equals negative 3. So here we add b over 2a squared to both sides. Because remember, what we're doing is we're making a perfect square that we can then factor into a square binomial. So we have x squared plus 4x minus, x squared minus 4x plus 4 equals 1. We're going to factor out that to x plus 2, x minus 2 squared equals 1. Take the square root of both sides, and we have x minus 2 equals plus or minus the square root of 1. X minus 2 equals plus or minus 1. We're going to add 2 to both sides. 2 plus 1 is 3. 2 minus 1 is 1. And so we have 3 and 1. Again, those are the zeros of the function. It's what happens when, we'll get into that later. But those are your answers for number 2. So next one we're going to do is number 6. It's a little bit tougher, but we also have the benefit of not having to divide by a. So we're going to put it in the right form, subtract 47 from both sides. And that's going to give us v squared plus 16v equals negative 43. So a equals 1, b equals 16. b over 2a equals 16 over 2 times 1, or 8, which I'm fine with. And then b over 2a squared equals 8 squared, which is 64. So that's the number we need to add to both sides in order to get a perfect square. We add 64 there, add 64 there. So v squared plus 16v plus 64 factors equals 21. Ugh. To v plus 8 squared. So we have v plus 8 squared equals 21. I ran out of room, so I'm going up top. And what I'm going to do is I am going to take the square root of both sides. And that gives me v plus 8 equals plus or minus the square root of 21. Subtract 8 from both sides. And I get v equals negative 8 plus or minus the square root of 21. Now, because 21 isn't a perfect square, we just leave it like that. If that was 16, we'd write plus or minus 4. If it was 5, we'd write plus or minus 20. No, if it was 5, we'd write plus or minus 5. So it's only if a perfect square that we don't do it. Everything else we just leave as is. So hopefully that was clarifying. Hopefully you guys understand not only the how of what we're doing, but the why of what we're doing. If you have any questions, let me know. Thank you and good night.